So this is the second of the pool deck assignments, and I wanted to run through one of the examples just to give you an idea of what it is we're going to be doing on this. It refers back to the first assignment that I made a video for, where we were looking at a variety of different pool and deck designs and coming up with functions that would represent the area of the pool, the area of the deck, and the total area based on some variable x that was within the design somewhere. So you can see this is pool number 4. The design for this pool and deck is that we have this square pool right here in yellow, and then built around it is this deck in pink, where it comes out 5 feet from the side of the pool here, 3 feet from the side of the pool here, and then it kind of finishes off a rectangle there. And so we calculated the total area function to be x squared plus 8x plus 15. And just to recall, what we did was we took the pool area to be x squared, because it was just x times x. Then we took the deck and we divided it up into 3 different rectangles by kind of drawing in a line here and another line here. And this rectangle was a 5-foot by x feet rectangle, so it had an area of 5 times x. This one was 3 feet by x feet, so it had an area of 3x. And this rectangle is 5 feet along this way, from the 5 up here, and 3 feet along this side from this 3 right here, so it had an area of 15. So altogether, this area could be found by just combining these 4 rectangles. So we had x squared plus 3x plus 5x plus 15, which turned into x squared plus 8x plus 15. So that's what we did yesterday. And today what we're going to do is we're going to investigate that function and use Desmos to find the vertex of the function, the y-intercept of the function, the x-intercepts of the function if there are any, and then answer this question: for what value of x is the total area equal to 48 square feet? And then we're also going to sketch a graph of this function, this space down here. So one of the first things I want to show you is I went ahead on Desmos and I put in that function into Desmos. So x squared plus 8x plus 15 was my function for the pool, and it produced this graph. Now the nice thing about Desmos is it'll tell you some of these important points that we're looking for. So for instance, we want to know what the vertex is. Well, right here it says the vertex is -4, -1. We want to know what the y-intercept is. Well, it kind of highlights that y-intercept right there, and it says that it's 0, 15. We also want to know what the x-intercepts are. So it'll highlight the x-intercepts down here, -3, 0, and -5, 0. So we can use these points, plus maybe another one right over here, -8, 15. It's kind of like the mirror image of this point, because we know there's going to be this axis of symmetry that goes right along here. I'm actually going to type that in. Let's see, that would be x equals -4. X equals -4 is our axis of symmetry. See, I know there's a way to change that color, but I'm not sure what it is right now. So this dark black line is like the mirror. It's like the mirror in a way that's reflecting one side of this parabola onto this part over here. So every point on a parabola kind of has a twin point on the other side of the axis of symmetry. So we can use this point, and this point, and this point, and this point, and then this point right here. Let's see if I can get it right on it. -8, 15. I can use that point as 5 points to kind of sketch my graph on this sheet here. So let's go through and work out some of these. First, it asks for the vertex. We know the vertex is a point, so it should have an x and a y coordinate. If I go back to my Desmos, I can see that that vertex, that lowest point on my parabola, is -4, -1. So let's write that in. -4, -1. And what this means is, in terms of like making sense of this problem from a real world standpoint, is this is saying that according to our function, the lowest or the minimum total area is -1, we'll say square feet. We'll assume that we're doing this in feet. Is -1 square feet. But we actually know that that's not true, because in order to get that minimum area, we would have to use an x value of -4 feet. Well, we can't have a pool that's -4 feet by -4 feet. So technically anything with a negative x value doesn't really make sense for this scenario. But this is what the vertex tells us according to our function. Next, we're going to look at the y-intercept. So I'm going back to my function here. Oops, wrong button. Let's get back to my function. There we are. And that x-intercept we know is the place where the graph is going to cross the x-axis. So that's at 0, 15. So I can go back in here and I can say that my x-intercept is 0, 15. Let's do that in same color, 0, 15. Let's just make a note what this is telling us. It's telling us that when x is 0, so when the dimension of the pool is 0 feet, the total area of the pool and deck combined is still going to be 15 square feet. That's because even if we didn't have a pool here, that means that this rectangle kind of wouldn't exist, and this rectangle kind of wouldn't exist because there would be no feet along here and along here. But this part of the rectangle of the deck would still be there that has an area of 15. So this says that with a pool of 0 feet by 0 feet, the total area is 15 square feet. So now let's talk about our x-intercepts. Let's go back to Desmos. We know that x-intercepts are the place where we're crossing the x-axis. So we can see one at -5, 0 and one at -3, 0. So this graph has two x-intercepts. So we're going to say our x-intercepts are -5, 0, and I already forgot what it was, -3, 0. And okay, what does this mean from like a real world standpoint in terms of this scenario in the real world? It means that -5 or -3 would be the values of x that would give us 0 total area. Well, that might not make a lot of sense for us in the concept of the real world because we know we're never going to have pools that are -5 feet wide or -3 feet wide. But that's kind of what it means. So let's write that down. A pool dimension of -5 feet by -5 feet or -3 feet by -3 feet produces an area of 0 feet squared. That's kind of what that's telling us. So let's jump down here to F and let's sketch the graph of this function. So to sketch the graph, one of the things I want to first do is I want to draw my axes. So my vertical axis, which is technically my area based on x-axis. So let me get rid of that. I wrote that wrong. That's my area based on x-axis. And then I have my horizontal axis, which is just going to be called my x-axis. And I'm going to plot these 4 points plus the one that we said is kind of like a twin of this x-intercept point. So I'm going to put the vertex at -4, -1. So I'm going to say that this is -4 and this is -1. So my vertex is going to be down here. Vertex -4, -1. I'm going to put my x-intercepts at -5, 0 and -3, 0. So we'll say this is -5 and this is -3. So I'd have my x-intercepts on my graph there and there. I'm going to graph my y-intercept at 0, 15. Let's say that way up here is where 15 is. So there is 0, 15. And then I'm going to do I like to have 5 points when I sketch the graph of a parabola. So I'm going to do the mirror image of this y-intercept point. Back to my graph, I had 0, 15. And on the exact opposite side of my axis of symmetry, I have -8, 15. So I'm going to put that on my graph as well. -8 would be maybe kind of out here, maybe around here. So -8, 15 would be right around there. -8, 15. And then I might go ahead and put in my axis of symmetry because sometimes that's kind of handy to have on a graph. So that's that vertical line that's going right through my vertex. And then I can go ahead and sketch out my parabola's graph. So it's going to come down here, and then it's going to kind of make a swoop. Oops, I'm going to miss that a little bit. Let's try that again. I'm going to come down here. It's going to swoop, and then hit that, and then right up to there. Okay, so that is a sketch of my parabola. Kind of contains all these important points that I highlighted. And then the last thing it says is, for what value of x is the total area equal to 48 square feet? So in other words, this is asking us to solve area of 48 equal to x squared plus 8x plus 15. Solve for what value of x in our function makes this side turn out to be 48. Now to solve this, you could move this 48 over to here and say minus 48 and minus 48, so that I have 0 equals x squared plus 8x minus 33. And I could use the quadratic formula to solve this and get two possible answers. Or I can use Desmos, and this will be really easy. Let me show you how I can use Desmos to solve this. All I'm going to do is I'm going to come in here and I'm going to say f of x equals 48, and it's going to tell me, if I zoom out here, it's going to tell me that an x value of 3 would give me a total area of 48, and that's going to be my answer. So I'm going to come back in here and I'm going to say x equals 3.